Let's solve this problem. If integral of sin x upon sin cube x plus cos cube x dx is equals to alpha times log to the base e mod of 1 plus tan x plus beta times log to the base e mod of 1 minus tan x plus tan square x plus gamma times tan inverse of 2 tan x minus 1 upon root 3 plus c, where c is the constant of integration, then the value of 18 times alpha plus beta plus gamma square is. So to find the value of the required expression, we have to solve this integral, and the answer of this integral will be in the terms and the answer of this integral will be in these terms. Then by simple comparison we will get the value of alpha, beta and gamma, and then by substituting in this expression we will get the required value. So our task is to solve this integration. So the integration of sin x upon sin cube x plus cos cube x. So when we have such kind of sine and cos function which is there in the numerator and denominator, then most of these questions can be easily solved by converting into tan x and sec x. Okay, so here also we can see that if we divide by cos cube x, so we get integration of sin x upon cos x will become tan x, and 1 upon cos square x becomes sec square x, upon again sin cube x upon cos cube x becomes tan cube x, plus this becomes 1 dx. So now it clearly says that we have to substitute let tan x is equals to t. So then the derivative tan x derivative sec square x dx equals to dt. Okay, so now after the substitution we get integration of tan x, it's a t, upon it's a t cube plus 1, and then sec square x dx becomes dt. So now we expand the denominator, we get integration of t upon t cube plus 1 cube, formula we get t plus 1 into t square minus t plus 1 dt. Okay, so now we are going to use the partial fraction to break these factors in the denominator. So now let's consider t upon t plus 1 into t square minus t plus 1. So this is equals to a upon t plus 1 plus bt plus c upon t square minus t plus 1. So since here it's a quadratic equation in the denominator, so in the numerator is going to be a linear. So now so what we get is t equals to a times t square minus t plus 1, t square minus t plus 1 plus t plus 1 times bt plus c. Okay, so now we will substitute some nice values of t so that we can quickly get the values of a, b and c. So now let's put t equals to minus 1 first. Put t equals to minus 1. So now what we get? We get minus 1 equals to 3a. Okay, so what does this implies? This implies that a is equals to minus 1 by 3. Okay, so now let's put t equals to 0. So put t equals to 0. So then we get 0 equals to minus 1 by 3 plus c. So this implies that c is equals to 1 by 3. Okay, now then we can take t equals to 1, because as we already know the value of a and c, and then by taking t equals to 1 we will get the value of b. So what we get is 1 equals to minus 1 by 3 plus b plus 1 by 3 into 2. Okay, so then we get 4 by 3 equals to b plus 1 by 3 into 2. So this implies that b plus 1 by 3 equals to 2 by 3, and finally we get the value of b, which is equals to 1 by 3. Okay, now let's substitute these values of a, b and c in equation 1. So then integral of t upon, so then we get integral of t upon t plus 1 into t square minus t plus 1 dt. Now by using partial fraction, what we get? We get minus 1 by 3, it's a value, okay, upon, it is t plus 1, so it's a 1 upon t plus 1 dt. Then we can write it as plus 1 by 3 integration of, then it's a t plus 1 upon t square minus t plus 1 dt. Okay, the value of b and value of c is 1 by 3. So now the first integral is easy. So this is equals to minus 1 by 3, and the integration of 1 upon t plus 1, it's a log of t plus 1. So now we got this expression, then plus, now we can exist the denominator derivative in the numerator. So the denominator derivative is 2t minus 1. So we want 2t in the numerator, so we'll multiply and divide by 2. So here we get 1 by 6 integration 2t plus 2 upon t square minus t plus 1 dt. Okay, so now we will adjust the numerator as per the denominator derivative. So we are going to get minus 1 by 3 log of t plus 1 plus 1 by 6, then it's an integration of, then it's a 2t, what we require minus 1, so we write it as a 2t minus 1 upon t square minus t plus 1 dt. Then we want plus 2, so we have to add plus 3, so it's an integration, then it's a 3 upon, so we can take 3 outside, 1 upon t square minus t plus 1 dt, and this 1 by 6 is there in the multiplication, so that 1 by 6 comes here, so 3 ones are 3 2s are 6. So now let's solve further. So what we get is, this is equals to, let's start from here, we get minus 1 by 3 log of t plus 1 plus 1 by 6, it's the log of the denominator because its derivative is there in the numerator, it's a t square minus t plus 1, okay, then plus, then it's 1 by 2 integration of 1 upon, it's a t square minus t plus 1, so let's make it a perfect square, so then t square minus t, then half into coefficient of t, the whole square, so that's nothing but 1 by 4, so we add plus 1 by 4, then we have to do minus 1 by 4, then it's a plus 1 which was already there dt. Okay, then the initial terms are already in the simplified form, so let's write as it is, then plus 1 by 2, the third term we are solving, 1 by 2 integration of 1 upon, it's a t minus 1 by 2 the whole square plus 1 minus 1 by 2, it's a 1 minus 1 by 4, it's a 3 by 4, so we can write it as a square root of 3 by 2 square dt. Okay, then we can use the formula 1 upon x square plus a square. So now 1 by 2, then it's a 1 by a, so it's a square root of 3 by 2, so let's write it here into 2, it's a 10 inverse of bracket, it's going to be t minus half by a, which is square root of 3 by 2. Okay, so then now we can actually add our arbitrary constant c. Okay, it's an indefinite integration, so then plus what we get 1 upon square root of 3, 1 upon square root of 3, and here it's a 10 inverse of bracket, then it's a 2t minus 1, and here we can do the resubstitution, so what we get is 2 tan x minus 1 upon square root of 3 plus c. Then similarly we have to do the resubstitution in the first and second function, so here we get it's a minus 1 by 3 log of 10x plus 1 plus 1 by 6 log of 10 square x minus 10x plus 1. Okay, now we have to compare this equation with the answer given in with the equation given in the question. So then we get the value of alpha, beta and gamma. So then now we can compare our answer with the answer given in the question of the integral, and we can, by comparison, we can get the value of alpha, beta and gamma. So we can see that alpha value is minus 1 by 3, beta value is 1 by 6, beta value is 1 by 6, and gamma value is 1 by square root of 3. Okay, and we want to find the value of the expression 18 times alpha plus beta plus gamma square. Okay, so now this is equals to 18 times, it's a minus 1 by 3 plus 1 by 6 plus 1 by 3. So the answer turns out to be 3. So this is the answer. Thank you.